Hello, hello. Let's do another grind 75 question. Still on week one. Got a bunch of easies here. So these are just warm ups. Valid anagram. Let's go ahead and pull up the iPad. Alright, let's make this smaller. Given two strings, S and T, return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically used using all the original letters exactly once. Why does it say typically there? Typically using all the original letters exactly once. So does that mean you can use it more than once? Okay, so anagram. Okay, so how do we even do this as a human, right? So anagram, let's say anagram and nagram. So, first thing I always think about is the skills that I need to solve this. It's probably some type of array iteration, and then probably some type of storage. If not storage, then a smart way to iterate through both. Because we're going to have to at least look at every character here, right? We're going to have to move this pointer and at least look at everything. And then maybe we can think about what would make this problem easy to solve, right? So what would make this problem really easy to solve? What version of this function is really easy? Imagine if the function that you're supposed to create has all the letter counts from the first word and then only the second word. So only the second word, right? So then in this case we can do, for letter and second word, we can just iterate through, and if the letter is in, let's just call it storage, then we decrement the letter, and if it's not in storage, then we need to return out of this function, right? Maybe return false. And then what we're doing is we're taking maybe this is the letter N, this is the letter A, this is the letter G, this is the letter M, and maybe there's one N in anagram, three A's, a G, an M. I'm missing one, and then R, right? So, as we're going through, let's make this green here. As we're iterating through one of the words, N, A, G, A, R, A, M, we can go ahead and we can essentially remove part of this, or at least decrement it, right? So this goes from 1 to 0, this goes from 3 to 2, this goes from, right? And the real example would be, you see the A, let's do you see the N, this goes to 0. You see the A, this goes to 2. You see the G, this goes to 0. You see the A again, this goes to 1. The R, this goes to 0. The A, this goes to 0. And the M, this goes to 0, right? You can imagine that if this was missing the M, then this does not go to 0, and there's a remaining M, right? So in this example, after we do this for loop, this iteration, we want to check, let's just call storage for now, and then if storage has any characters, has length, then return false. Otherwise, we want to return true, right? So this is one way to solve this, probably, right? You have an anagram, you have two words, maybe one of them becomes a counter object, right? This becomes a counter, and then the second word, as we're iterating over it, we're just decrementing this counter. The counter is going to allow us to see what is the actual remaining letters. So that's one way. We can think of a clever way without storage. So I guess a clever way without storage is, if you're given a string 1 and string 2, what would be really easy is what if I gave you string 1 is sorted and string 2 is sorted, right? And all you had was some type of string that's like this, AABC, ABCC. Then you can have 2 pointers, and you can just move the pointers. First, you can check if the lengths are the same, but after you do that, you can go ahead and move the pointers and see if they match, right? Once you get to this A and this B, you find that they do not match. And if they're the same length, well, they have to be the same length, right? So it's an optimization. So I guess there's 2 ways to do it. There's one if it's sorted. So, solution 2 is if they're sorted, it makes everything easier. Solution 1 is use storage and create a counter object. And we can think through other ways to solve this. I guess, if you didn't care about time complexity and you mostly cared about storage and you didn't want to sort for some reason, like maybe these are unsortable items, like this is a string so it won't be unsortable, but maybe you have a collection of user objects or something that cannot be sorted, and I guess you'd have user IDs. But I guess one thing you could do is, these are unsortable, you can do this in n squared runtime, and just for when you find an A, you go through the string to look for the closest A and then delete it. And you find the N, you go to the string, you look for the closest N, you delete it, and then you can delete that. Doesn't require any extra space, but requires extra runtime. So this counter version is pretty easy. So you can just go ahead and use it. So the thing is, in Python, there is a counter collections object. Not 100% sure how to use it without looking at documentation. So in an interview, I probably won't be able to do this correctly on the first try. So I'm just going to use a dictionary. So what is our code going to look like? So our code is going to, if we have storage, so we're going to create a counter object of the first string of S. And then we're going to, for letter in T, if in storage, we're going to decrement. And then, I guess if the value is 0, we can go ahead and delete the key and else return false. And then, check storage here. So this is the basic skeleton of the function, right? So how do you create a counter? Let's just say we have a counter object here, and we're going to, for letter in S, if the letter is in the counter, or let's just say if it's not in the counter, then the counter letter equals 0. And then else, if it is in the counter letter will equal whatever is the value there plus 1. We'll increment it by 1, right? And then that's our counter. That's pretty simple. That's this object right here that we're using for storage. And then we're going to move on. Okay, so this is step 1. We're going to move on to this for loop, right? So for letter in T, we're going to do something different. We're going to check. So if this letter is in this counter, then great. We're going to do something. If it's not, we can actually just return out of this function, right? This would be an early return. And let's think through the steps that we have to do here. So if it's in the counter, then what we want to do is decrement the counter, right? So the counter at this letter equals whatever was the value there, counter at the letter minus 1, right? And let's, for our convenience, if the counter at the letter is now equal to 0, we're going to go ahead and delete the counter at the letter key. Awesome. So you'd imagine in the perfect scenario, you know, instead of marking everything down to 0 like we're doing here in the diagram, instead of doing this, we end up with an empty dictionary if we've deleted everything, right? So if n is 0, r is 0, g is 0, they don't actually stay 0 because we'll delete the key, and then we'll have this empty dictionary, right? Okay, so checking the storage is actually checking that. So if counter.keys, I believe this should be a list. It might be an iterable. If it's an iterable in Python and you want list functionality, you have to turn it into a list. So if the length of this list, and maybe I can do length of counter.keys, I'm actually not sure. You know, this would be great, honestly. So if there's no keys, then we're done, right? This is a good situation. It's a valid anagram. Else, cannot. Turn false. I don't know if we can do this. We can check. Let's just run it and see if it works. If this doesn't work, then we have to turn this into a list. I don't know if this doesn't work because of what I did. That's funny, huh? So this test case returns false. This test case also returns false. Let me just try. Length of the list. I don't know if this is an iterable or if it's a list. Okay, so the problem's a real problem. That's good. So we expected true, but we got false. Awesome. Perfect time to look at what happened. So let's kind of walk through what happened. So we have anagram and we have nagram. These two. Anagram, nagram. So for the first one, we're building this counter object that we've built here. And let me just delete some stuff. And let's just see if this is what we expect. So A should have 3, N should have 1, G should have 1, M should have 1, and R should have 1. So let's just look at our code. We're not going to print here. We're going to try not to print here because you can't print an interview in some places. So we have a counter here for the letter in S. If the letter is not in the counter, then we set it to 0. Or else if it is in the counter, then we're going to take that and we're going to increment it by 1. So this seems totally fine. I'm going to refrain from printing, but I will put it here so we can print it in a bit. So we can look at that and imagine that this is the counts that we are expecting, which is right here. Now for letter in T, if the letter is in the counter, then we know that it has a value that's at least 1. Then we're going to take that letter in the counter and we're going to make it equal to the letter in the counter minus 1. We're going to decrement it. So totally makes sense. And at that point, if the letter at that counter is equal to 0, then we're going to delete it. And I hope that's how you delete it. I don't remember for certain if that's how you delete from a Python dictionary, but I hope that's how you delete it. Great. And if the letter is not in the counter, then we want to return false. Now, is this how that works? Does typically using all letters exactly once, does that mean you could use the letters more than once? Okay, well, what is this one? What is this supposed to be? Right, so it has an N, it has 3 A's, it has 1 G, has 1 M, has 1 R. So it should perfectly match. what's going on here? What happens if we print the counter the second time? So counter.keys. So the counter.keys, it should be 0. So here's what we're printing. We're printing interesting. So it's only printing it the first time? Which one is it printing? Is it printing this one? Is it printing this one? That means it's only printing the first one. Oh, I see the problem. I actually don't need the else there. I set that to 0 because I didn't want the else there. I see the problem. So that's a bug, right? So if you're setting it to 0, you're just expecting, you know, some other code to increment that in the future. If you want to make this one-liners, you could do this and see if it equals to 0. So I'm going to, to delete that. I'm going to delete this list and just see if this works in Python. See if you can return the length of a counter.keys, where counter is a dictionary. Oh, it does work. Okay. So let's take a look at our diagram, see if we've done everything we wanted to do. So we didn't write the code of building it, and that's where we went wrong. Maybe we should have wrote the code of building the counter. And we did everything we wanted to do. But there is this one thing that I brought up here where if it's of different length, then you can go ahead and get rid of it, right? So if length of s is different than length of t, then you can go ahead and return false. And that's an early termination. Is there anything usable we can use in the future here? Is this a trivia problem, or is this a fundamental coding problem? Well, building a counter is something you have to do often, especially for these types of problems. Thinking about early termination, you're going to have to do often. Judging against that counter, probably something you're going to have to do often. The one thing you could do to skip this is to use the counter in Python. Now, I don't remember the syntax, and I'm not going to look it up, but it's probably something like from collections import counter, something like this, right? And then the counter takes some type of iterable, and it might be the whole thing. It might just take s here, and then counter becomes something you can use. It's basically what I just did, but less error prone because I had that error. So this is going to crash, but it's going to print my C. So C's here. So perfect. It's a counter here. And we're going to want to interact with the counter. Now, I don't know if this is going to be the same syntax, but it might be something like C here. And then, I'm not just going to, I'm just not going to guess, but you'd imagine if you knew Python a little bit more than I do right now, that this counter is super helpful. It would completely help you get rid of this bug, right? I'm just going to see what it's like to, so I know the A is in here. So if the A is in C, then I'm going to do it outside where AC, let's see if I can do minus equals 1. See what happens to that counter. Okay, so it does let me do that. And let's see if I can delete. See if I can delete the A and see what happens there. And if I can delete the A, then this works exactly how I did it before, right? So forgot to print. So if you see here, I have 3 prints. I have a print for the counter, I have a print to try to decrement, and I have a print to try to delete. And there we go. It does delete it. So the only thing left is if I have c.keys. If I have keys in this counter, then I could perfectly use this counter the same way I used my dictionary, and then I didn't have to go through all that trouble. This is perfect, right? So go ahead and delete this, and I'll just comment this out so I don't run over it. But for letter in T, if the letter is in C, then C, which is my new counter, at that letter equals C at that letter. And if I want to, I can even do minus equals 1. And then if C at that letter is equal to 1, then I can delete C at that letter. And then if it's not in there, I want to return false. And then here, I'm going to return the length of c.keys and whether or not it's equal to 0. So let's see if this one runs. Alright, so we learned how to use at least the basics of counter, or I kind of just made it up. Let's see if we can submit it and see what happens. Awesome. So the runtime's 24, memory is 47. Let's just run this twice, see if there's any significant changes. Okay, so memory is like way less now. And just for fun, let's see what happens. Get rid of that solution, bring back that solution, get rid of, bring back that, bring back the counter. You know, this is just not going to be accurate. We're probably going to have to run it a couple thousand times to make this accurate, but let's see if how this compares to the Python counter collection versus our hand-built dictionary counter. Alright, so the memory is a lot less. Now it only takes, you know, now we're beating it out. Don't know why that is. I would imagine this is more optimized, but thanks for coming. This has been fun. This has been Valid Anagram.